Okay, so the system we want to solve is x plus 2y minus z equals 1, 2x plus y plus 3z equals 5, and 3x plus y plus 2z equals 8. We are going to solve this through elimination. Okay, so what I'm going to do is I'm going to write out the steps we need to solve this through elimination, and at the same time we'll do each of those steps together. So step number 1, we want to choose any two equations and eliminate one of the variables. It doesn't matter which equations you choose. So you tell me, which two equations do we want to choose? Ange? I'm sorry? The second and third, sure, perfect. I like those, and I think those are our best options. 2x plus y plus 3z equals 5, and 3x plus y plus 2z equals 8. And which variable is the best option to eliminate? Y. Right now they're both positive, but we can really fix that. I'm going to distribute in a -1, multiply both sides by -1, and that will fix that. So now when we go to add this, we get 2x minus 3x is a -x. Then we're going to get positive y plus a -y. Doesn't that cancel? And then we have 3z minus 2z is a positive z, and that's going to equal 5 minus 8, which is a -3. All right, now what we're going to do is we're going to choose two different equations. So step number 2, we're now going to choose two different equations and eliminate the same variable. So what do I mean when I say eliminate the same variable? In step 1, we chose to eliminate the y. So now we're going to choose a different pairing of equations, and we're going to eliminate the y. So let's go back. Really doesn't matter which ones you choose. We already chose the second and third one, so we can't choose those two again. We already did that. So now we have to choose a different pair. Which pair do you want to choose this time? It doesn't matter. Do you guys want to do the first and the second? Let's do that. So we're going to say x plus 2y minus z is equal to 1, and 2x plus y plus 3z equals 5. Now we need to make the y's cancel. In order to make the y's cancel, I must multiply the whole bottom equation by what? -2. So my top equation stays the same. My bottom equation, I will now have negative 4x minus 2y minus 6z equals negative 10. And now we solve. So I have a positive x minus 4x is a negative 3x. The y's cancel. Negative z plus a negative 6z is a negative 7z, and that will equal negative 9. Okay, now what we're going to do, our next step. Yes.
Yesterday you said we would like finish up with 7 first, because I get the right answer.
Oh, after I do this problem, I'll go back to it. I forgot about that. Okay, so now what we're going to do, step number 3. We have a system of 2 linear equations in 2 variables was created. Solve the system. Okay, I'll explain to you what I mean by that. Now, between step 1 and 2, didn't I get 2 different equations? Both of them dealing with just x and z, no y's. So we're going to take these 2 equations that we sort of manipulated to get, and we're going to solve the system using these 2 equations. So I'm going to line them up. I have negative 3x minus 7z equals negative 9. And now I have a negative x plus z equals negative 3. Let's eliminate the x. What should I do to eliminate the x? Multiply it all by negative 3. So now I have negative 3x minus 7z equals negative 9. Then I have a positive 3x plus a minus 3z plus equals positive 9. And now we add. The x's cancel. So I'm left with a negative 10z equals 0. Divide by negative 10, we get z is equal to 0. Is that okay? Absolutely, that's okay. What do you think I'm going to tell you to do now? Good. We're going to sub back in to find other variables. All right, so I'm going to use negative x plus z equals negative 3. I'm going to sub in that z equals 0. So negative x plus 0 equals negative 3. Well, if negative x equals negative 3, x equals positive 3. Am I done? No. What do I have to do now? I have to find y. Can I use any of these equations to find y? The ones here that I have written above? No. What do I have to go back to? I have to go back to the original. None of these equations that we have here have y in it. So in order to find y, I need to go back to one of the originals. So I'm going to go to my second equation. which was 2x plus y plus 3z equals 5. Well, now we know that x is 3. We know y is 0. Oh, no, we don't know y is 0. We know z is 0. Sorry, we're solving for y. We know z is 0, and we're solving for y. So we have 6 plus y equals 5, so y will equal -1. So we, just to list it all out, we get x is 3, y is -1, z is 0. All right, are we ready? We're going to go back to the one I had left off on that I forgot about. Sean, was it the 1 over r plus 2 over s equals 8? Is that the one? Okay. So this is from yesterday that we never got to go over. 1 over r plus 2 over s is equal to 8. And 5 over r plus 1 over s is equal to 7. I'm going to decide to cancel out the s's. So I'm multiplying the bottom whole equation by -2. So my top equation stays the same, but my bottom equation is going to be -10 over r minus 2 over s equals -14. When we add, we are going to get -9 over r, the s's cancel, equals -6. Okay. We'll keep going. We're going to cross multiply here. I'm going to get -6r is equal to -9. We will get r is equal to 9 over 6, but we can simplify that, so we get 3/2. Now that we have r, we want to solve for s. To solve for s, I'm going to go back to one of my originals. I will go back to 1 over r plus 2 over s is equal to 8. And I'm going to sub in that r. So 1 over 3 over 2 plus 2 over s is equal to 8. Now remember, we don't get intimidated by this. This is not intimidating. What is this? This is just 1 divided by 3 over 2. Keep, change, flip, right? This becomes 1 times 2/3. So that whole thing is just 2/3 plus 2 over s is equal to 8. I'm now going to subtract my 2/3 on both sides. So 2 over s is equal to 8 minus 2/3. In order to subtract these, I need to make a common denominator. So I'm going to have 2 over s is equal to 24 over 3 minus 2 over 3. So now we get 2 over, not s. We get 2 over s is equal to 22 over 3. Now we cross multiply, and I get 22s is equal to 6. S will equal 6 over 22, which can be simplified to 3 over 11. So just to recap, my r is 3/2, my s is 3 over 11. We good? All right, moving on to day 2. Okay, so matrices is plural. The singular form of matrices is a matrix. And a matrix is a great way to organize data. You're going to see we could actually even use it to solve systems of equations. And what does a matrix look like? A matrix is a rectangular arrangement of rows and columns of numbers. Each number is called an element. Put a little star, and we're going to say matrices are named with capital letters. So for example, I could have matrix A and notice how I've made brackets here. That's sort of like a rectangular arrangement. I've made those brackets. It cannot be straight lines. The straight lines mean something else that we'll talk about in a little bit. So they have to be like sort of squared off brackets. So let's say I just have numbers 1, 6, -10, -9, 0, 7. So this vertical grouping is called a column, and the horizontal grouping is a row. And when we talk about the dimensions of a matrix, will always be row by columns. Okay, so what do I mean when I say it will always be rows by columns? You go to your matrix and you count how many rows do you have. 1, 2, 3 rows. And then you count how many columns you have. 1, 2. Because there were 3 rows and 2 columns, this is going to be considered a 3 by 2 matrix. A matrix is called a square matrix if the number of columns is equal to the number of rows. Okay, so this example, is this considered a square matrix? Absolutely, because it is a 2 by 2. Number of rows is equal to the number of columns. right, next vocab word, determinant. So the determinant of a matrix is a real number that can be calculated from a square matrix. Okay, the symbol for determinant are two vertical lines. Right, let me give you an example. If I write something like this is not the absolute value. This is going to be the determinant of matrix A. And you could only find the determinant on square matrices. If it's not a square matrix, you're not able to find the determinant of it. All right, so how will we calculate the determinant? To calculate the determinant, there's different methods depending on the size of the matrix. So let's write calculating So the first scenario will be a 2 by 2. So if you have a 2 by 2 matrix and you're going to find the determinant of it, we'll say A, B, C, D. Those are my elements. What you're going to do is you're multiplying on a diagonal. So it's going to be AD, you multiply on a diagonal, minus the other diagonal, which is BC. All right, let's do a couple examples. So I want us to find the value of each determinant. So what we want to do is we want to multiply on a diagonal. So 2 times -5 is a -10. Then we want to subtract the product of the other diagonal. So -3 times 1 is a -3. So here we have -10 minus a -3. That double negative makes a positive. So it's -10 plus 3, which is -7. Yes. Yes, because these are determinants. So for matrices, they're brackets. For determinants, they're straight lines. Okay, let's say I have 1/3, -1/5, 1/6, 3/10. I know I need to find the determinant. They're in the straight lines, so we're going to multiply on the diagonal. So I'm going to have 3/30 minus -1/30. The double negative makes a positive. So we are going to get 4/30. Oh, can this be simplified? Yep, and if you can simplify, you must simplify. So we are 2/15. So once again, we're going to find the determinant. I multiply on a diagonal. But this time, I'm multiplying 5 times the quantity of m plus n. Now be careful. It's not a plus. It's minus -3 times the quantity of m minus n. What happens with this double negative? It becomes positive. So we have 5 times the quantity of m plus n plus 3 times the quantity of m minus n. So now we distribute in. We have 5m plus 5n plus 3m minus 3n. We now combine our like terms and we get 8m plus 2n. What number is this? Okay, so now what I want us to do is evaluate and simplify. Can somebody tell me, how do I know that I need to find the determinant, that these are determinants that are asked and they're not just matrices laying out my data? Sean?
Because they have the straight lines.
Because they have the straight line. So we know that they want us to find the determinant because they have the straight lines around them. So what's going to happen? I have a determinant and then I have to find another determinant, and then what do they want me to do with those two determinants, do you think? Any guesses? Multiply them, exactly. So we're going to find the first determinant, we're going to find the second determinant, then we're going to multiply them. So we are going to get 4 minus -2, which is a positive 6. And then we're going to get 2 minus -15, which is a positive 17. And then we're going to take the two determinants and multiply them. 6 times 17 is 102. How am I doing on time? What do we have left? Oh, good. Okay. All right, so what is the purpose of these determinants? These determinants are actually going to help us solve systems of equations, and I'm going to show you how. There's something called Cramer's rule. And we're going to use this on 2x2 systems. And Cramer's rule is a method of solving linear equations using determinants. Are we ready? So I'm going to do an example, and I'm going to write out the steps and solve it at the same time, similar to what we did with the system, with the 3 variables. So let's say I want us to solve using Cramer's. So I'm going to have 3x minus y equals 7 and negative 5x plus 4y equals negative 2. Now, I know we can solve this a lot quicker just by using elimination or substitution or any of the other ones, but I want to solve using Cramer's so we get the hang of solving using determinants. So what we want to do, first part, we are going to find the determinant of the coefficient matrix. I'm going to call this D. Well, all right. So now I'm going to call this D the determinant of the coefficient matrix. So because I'm finding a determinant, am I going to use the square brackets or the straight lines? Straight lines, because I'm finding the determinant. Now the coefficient matrix are just basically the coefficients. What are my coefficients? I have a 3 and a negative 1. And then what else do I have? Negative 5 and 4. I literally just pulled the coefficients. Find the determinant. If we're finding this determinant, we are going to get 12 minus 5, which is 7. So I get D is equal to 7. The determinant of the coefficient matrix is 7. We're sort of putting this on the side burner right now. We're going to come back to it, but we need to do some other things. So next step. What we want to do now is use determinant D, but replace the X column with the equal values. So write it down and I'll explain to you what I mean. Are we ready? Okay, so we're going back to my determinant D, and remember I used the coefficient matrix. I made a matrix of just the coefficients inside of this. What we want to do is we're using this, but now I'm going to replace the X column. Wasn't the X column 3, negative 5? I'm going to take that X column and I'm going to replace it with the equal values. What are the equal values? 7 and negative 2. It's what comes after the equal sign. So now I'm going to call this determinant D sub X because I've substituted in for the X values. So D sub X will be Instead of 3, -5, I'm now adding in 7, -2, and my y column stays the same at -1, 4. And now I find the determinant of this. So this is going to be 28 minus 2, which is 26. So d of x is equal to 26. Okay, wait for it now. If we want to find what x is equal to, x will equal d sub x over d. So what does that mean for us? X is equal to my d sub x, which is 26, over my d, which is 7. So my value for x in the system of equations is 26 over 7. Am I done solving the system? No. I've solved for x. What have I not solved for? Y. We're still using Cramer's. We can't now just go plug in. We have to continue using Cramer's. So now what I'm going to do, we're going to go back to D, but this time replace the Y column with equal values. And we're going to call this D sub Y because we're subbing out the Y's. So we go back to our original, which is D. Now my first column, the X column, is now staying the same. So it's 3, -5. But my second column is going to change. My second column, instead of -1, 4, what am I going to sub in? 7, -2. And we find the determinant. So we are -6 minus -35. So we get D sub Y is equal to 29. What do you think Y is going to be if you had to take a guess based on how we found X? Any guesses? Yeah, you got it. It's going to be D sub Y over D. So Y is going to be 29 over 7. So solving this system, our solution, where these two lines cross, will be 26 over 7, comma 29 over 7. Yes.
Could you go up real quick?
Sure. Going up to where?
So like the X or like steps B.
Sure.
That's right. Well, it's a lot easier if you don't understand what I'm saying. So I just don't make sense. And that reading, so.
All right, I'm going. Sign, can I scroll down? Are you still copying?
No.
You good? You got the rest of it?
Yeah.
Okay, so now I'm going to have you try one on your own. I want you to solve the system using Cramer's. Something's wrong. Could you tell me what's wrong here before we set up our determinant? Only Ange sees it. Brenna?
The x and y is 6x equals 1, which is
Good. When you set up these matrices for the determinants, what you want to do is you want to make sure that the variables are on one side and everything else is on the other side. So you need to manipulate this one by bringing that y over. So 6x minus y equals negative 11. And now you could go through and start finding your determinants.
Not 18 months. Yeah.
All right, who has an answer for me? Sean, what'd you get?
X is negative 3 halves, y is 2.
I got that. Does anybody need to see me do it? Okay, we can do it. Okay, so I'm going to first find the matrix, the determinant of the coefficient matrix, which I will call D. So the coefficient matrices will be 2, 3, 6, negative 1. And for me to find that determinant, we're going to do 2 times negative 1, which is negative 2, minus 6 times 3, which is 18. So that's going to give us negative 20. So the determinant of the coefficient matrix, which we call D, is negative 20. Now we're going to find D sub x. When we find D sub x, what we're doing is we're subbing out the x's. So instead of 2, 6, I'm going to put the equal values, which is 3, negative 11. But my y column stays the same. And now we find the determinant of this, which is negative 3 minus negative 33. That double negative makes a positive, so we're down to 30. So D sub x is 30. Now I'm going to find D sub y. And now for D sub y, we go back to our original D matrix. We're going to keep the x column, which is 2, 6, but now we're subbing out the y column. So instead of 3, negative 1, I'm now subbing in, 3, negative 11. Cross multiply, multiply on the diagonal, we get negative 22 minus 18. So we are going to get a negative 40. So D sub y is negative 40. So my x is going to be D sub x over D, which is 30 over negative 20. So my x is negative 3/2. My y is going to be D sub y over D, which is negative 40 over negative 20, and that is a positive 2. And that is our value. That is our solution. All right, we're done for today.